Hi guys, welcome to Equilibrium Lab. Now this is another Spec 20 lab, and you've already seen me run through using the Spec 20. And I had kind of a video disaster, and the camera ate the video, or I didn't push the button correctly. Who knows which one it was. So I'm going to run through the lab with you today and give you the data, show you how to deal with the data from this lab. You've already watched me use a spectrophotometer. Okay? Now, we're using iron 3+ ions, which comes from iron 3 nitrate, and we're going to react them with a thiocyanate ion, which comes from potassium thiocyanate. And this reaction we're going to allow to come to equilibrium, where we make the iron 3-cytothionate complex. This guy is orange, red. Okay? Now, through spectrophotometry, it's the concentration of iron thiocyanate that we're going to be after. In part 1 of the experiment, what we're going to do is we're going to create a standard curve. So we're going to take 3 solutions where we know the concentration of iron thiocyanate, and we're going to measure the absorbance. Now, we do this by using a limiting reagent. I put in very little iron of the thiocyanate, lots and lots of iron, so we force this reaction to completion where all the thiocyanate was converted over into the iron 3-thiocyanate, say that 3 times fast, complex. Okay? So our solution 1 had a 1.04 times 10 to the minus 4 molar concentration of FeSCN2+, and its absorbance was 0.430. Our second solution has a concentration of 6.24 times 10 to the minus 5 molar FeSCN2+, and the absorbance here is 0.235. And the third solution was 1.67 times 10 to the minus 5 molar FeSCN2+, and the absorbance is 0.122. Now, this you're going to use to make your standard curve. Your concentration is your X value, your absorbance is your Y value. Okay? And I want you to do your graph, include your graph with your lab, and give me the equation for the line. Okay? Now, the next thing we did is I made a series of 5 beakers with adding in the iron 3 ions, the thiocyanate ions, and some nitric acid, and I allowed this system to come to equilibrium. I didn't add a limiting reagent. We didn't have a limiting reagent, so this system is going to come to equilibrium. And for the 5 beakers, we get the following data. Okay? 1, 2, 3, 4, 5. The absorbance in beaker 1 was 0.099. For 2, it was 0.135. For 3, it was 0.157. For 4, 0.169. For 5, 0.190. Okay, so get those on your data sheet. Now, to find the concentration of FeSCN2+ in each one of the beakers, you're going to use the equation that you got for your line. Now I'm going to give you a made-up equation. So let's say I got y is equal 4,556x plus 0.027. Now this is a made-up equation. You'll get your real equation from your graph, okay? What I want to do is I want to find the concentration. Concentration is X. Y is absorbance. So I would go for run 1, 0.099 is equal to 4,556x plus 0.027. So I'm going to solve this for X. So 0.099 minus 0.027 divided by 4,556 gives me X is equal to 1.58 times 10 to the minus 5. Okay? Now, let's talk about how we're going to use that. All right. On your data sheet, you have ICE tables. Okay? Now you have the ICE there, you have the iron 3 plus, you have the SCN 1 minus, and FeSCN 2 plus. FeSCN to begin with is 0. Your change line I've already written in for you. It's minus X plus X. Everything's in a 1-to-1 ratio. And so this is X. Now I need to get these initial concentrations. To get the initial concentrations, we're going to look at our filling chart, okay? And think about doing a dilution. So for the iron 3 plus on this chart, I'm going to go 0.002 times 5 milliliters divided by 11. And so this is 9.1 times 10 to the minus 4. That's going to be the value on your table. And then for our thiocyanate, it's 0.002 times 3 divided by 11, because that's our total volume. And this is 5.5 times 10 to the minus 4. So here I have 9.1 times 10 to the minus 4, 5.5 times 10 to the minus 4 minus X, and X. Now, this is our X value. So this would be 1.58 times 10 to the minus 5. So 9.1 EXP4 negative minus 1.58 EXP5 negative gives me 8.9 times 10 to the minus 4. 5.5 EXP4 negative minus 1.58 EXP5 negative gives me 5.3 times 10 to the minus 4. Now, I'm going to asterisk this, okay? These are not the values that you're going to have on your table because this is not your equation. This is just an example. Okay, now once you have all of your concentrations at equilibrium, let's look at the K expression. K is equal to the concentration of the complex FeSCN 2 plus divided by the concentration of iron 3 plus times the concentration of the thiocyanate ion concentration. So for this reaction, okay, I'd have 1.58 times 10 to the minus 5 over 8.9 times 10 to the minus 4 times 5.3 times 10 to the minus 4. Okay, so 1.58 exp5 negative divided by 8.9 exp4 negative, hit equal, and then divide by 5.3 exp4 negative. And I get a value here of 33.5. Okay, again, this is an example. I better not see that number or this exact data chart on anybody's lab sheet. Okay, this value and this value are fine. These I've already typed in for you. This line and this line should be your own data from your own equation. Now you're going to do that for all 5 of your beakers where we allowed things to come to equilibrium. You're going to get 5 K values and you're going to give me an average K value. So go forth and conquer. Remember to include your graph with your lab report. Bye-bye.